Hello, good evening, students. So let me continue the problems on atoms chapter, students, today. Look at this problem. Energy levels A, B, C of a certain atom corresponding to increasing values of energy, that is EA, EB, and EC. So what is the energy in the orbit A? EA. What is the energy in the orbit B? EB. What is the energy in the orbit C? EC. Whenever this electron takes a transition, the wavelength emitted are given as lambda 1 when it comes from C to B. When it comes from C to B, the wavelength corresponding to that is H1. When the electron comes from B to A, the wavelength is lambda 2. So B to A, this is lambda 2. And C to A, that is lambda 3. Which of the following statement is correct? They are expecting. Which of the following statement is correct? They have given the options in terms of wavelength. They have given the options in terms of wavelength, students. So what you can tell, look at the diagram. Whatever the energy gap is there from EC to EB, let it be E1. And whatever the energy gap is there between B to A is E2. Energy gap from C to A, let it be E3. So by the conservation of the energy, E1 plus E2 must be equal to E3. So according to the conservation, E1 plus E2 must be equal to E3, isn't it? The energy from C to B plus the energy from B to A must be equal to the energy from C to A. So E1 plus E2 is equal to E3. What is E1? Hc by lambda 1. What is E2? Hc by lambda 2. What is E3? Hc by lambda 3. So you can cancel out with Hc, Hc, Hc. So the left out term will be 1 by lambda 2, 1 by lambda 1 plus 1 by lambda 2 is equal to 1 by lambda 3. So what is the LCM out? Lambda 1, lambda 2 will be the LCM. So in the numerator, we will get lambda 1 plus lambda 2, that is equal to 1 by lambda 3. Taking reciprocal, lambda 3 is equal to lambda 1, lambda 2 by lambda 1 plus lambda 2. So lambda 3 is equal to what? Lambda 1, lambda 2 divided by lambda 1 plus lambda 2. That is option B is the right answer. So lambda 3 is equal to what? Lambda 1 into lambda 2 divided by lambda 1 plus lambda 2. So option B is the right answer. Correct, no? Yeah. Come to the next problem, student. Now they are asking you to find the ratio of energies of the hydrogen atom in the first to second excited state. First to the second excited state. Now, this is called the ground state. N is equal to 1 is called as the ground state. If I considered energy in the second orbit, this is called the first excited state. If I take n equals to 3, 3 to 1 is called the third excited state. The ground state is called N1. This is called the first excited state. This is the second excited state. So n is equal to 1 is called as the ground state. So which is the first excited state? 2. So first excited state means it is 2. And second excited state means 3. So please remember, the electron is going to excite from 2 to 3. Exciting from 2 to 3. Now, the energy and orbit number, how they are related? Energy is inversely proportional to n square, isn't it? mz square e power 4 divided by 8 epsilon naught square n square h square. That is the energy formula, no? Energy in the nth orbit is minus m e power 4. For hydrogen atom, I am not writing z square. By 8 epsilon naught square n square h square. How energy and the orbit number are related. Energy in the nth orbit is inversely proportional to 1 by n square. So clearly this tells energy in the first excited state, that is E2, divided by the energy in the second excited state, that is E3. So what is E2 by E3? You know that En is inversely proportional to 1 by n square. So what is E2 means? 1 by 2 square by 1 by 3 square. This is equal to 1 by 4 divided by 1 by 9, which is equal to 9 by 4. 9 numerator, denominator of a denominator goes to numerator. So what will be the energy in the first excited state to the second excited state? That is 9:4. That is option C. Got it? Okay. Yeah. Come to this problem, students. Now, electron is jumping from which orbit to which orbit? Fourth orbit to second orbit. Fourth orbit to second orbit. The Rydberg constant is 10 power 5 per centimeter, or you can take 10 power 7 per meter. It is in centimeter. You can convert into per meter. Now they are asking you to find what is the frequency in hertz. Frequency in hertz. Now, you know that whenever the electron jumps from fourth orbit to second orbit, the energy emitted is equal to E4 minus E2. Since electron is coming from fourth orbit to second orbit, energy emitted will be equal to E4 minus E2. Now, you know that pretty well, the energy in the nth orbit of an hydrogen atom. This is hydrogen atom, right? Yeah. Energy in the nth orbit is given by the formula E1 divided by n squared, or you can take minus 13.6 divided by n squared electron volt. So how to find the energy in the fourth orbit then? How to find the energy in the fourth orbit then? It is minus 13.6 divided by n squared, that is 4 squared 16. That is minus 0.84 electron volt. This is the energy in the fourth orbit. Now, you want the energy in the second orbit also. In the same formula, can't you find what is the energy in the second orbit? That is minus 13.6 divided by n squared, that is 2 squared, that is 4. That is 3.4 electron volt. Minus 3.4 electron volt. So if you know E4 and E2, can't you calculate the energy emitted when electron comes from fourth orbiter to the second orbit? Yes, you can. What's the formula? E is equal to E4 minus E2. What is E4? Minus 0.84. Minus of minus will be plus 3.4. So E is equal to, what is 3.4 minus 0.84? Yeah. 3.4 minus 0.84. It is around 2.56 electron volt. So this is the energy emitted by the electron when it comes from, yes, fourth orbit to second orbit. But they are not asking you to find the energy. They are asking you to find the frequency. They are expecting the frequency, isn't it? Yeah. Sir, how to find the frequency then? Why you have find the energy? Because without the energy, you can't find the frequency. Energy emitted by the radiation is given by the formula E is equal to h into nu. What is energy? It is 2.56. It is in electron volt. Convert into a joule. 2.56 into 1.6 into 10 power minus 19, which is equal to h into nu. I will keep nu as it is because I have to find that. If I don't want this h in the right hand side, I can take that to the denominator of LHS. Instead of writing h, shall I write it as 6.625 into 10 power minus 34? Instead of writing h, I'm substituting the value of h. That is 6.625 into 10 power minus 34. Yeah. So what will be the nu then? You can multiply these two and divide by 6.625, right? So if you multiply 2.56 into 1.6, you will find to be 4.096. If you divide that 4.096 divided by 6.625, you are going to get 0.6182 into 10 raised to, when you take minus 34 to numerator, it becomes plus 34 minus 19 will be equal to 15 hertz. So 0.6182. So, but they are not given in terms of the fraction. But I will look, 10 power 15 is there, here 10 power 5 is there. So this option is ruled out anyway. Then if you divide 3 by 16, it will, if I put 0 point, it will become 30, right? What is 30 by 16? It is approximately 0.2, but I required 0.6. And you know that 3 by 4 is what? 3 by 4. It is approximately 0.75. Even this 9 by 16 also 9 by 16. How much you'll get 9 by 16? 0.56. So this is approximately 0.56 into 10 power 15. 3 by 4 is approximately 0.75. 3 by 16 is approximately 0.2. but our frequency is close to 0.61. You can consider 0.56. So option C will be the right answer. You can keep it as 9 by 16, approximately very close to 0.6. So closest answer you can go with option C. Therefore, option C is the right answer. Got it? Okay. Let us move on to the next problem. Let us move on to the next problem. Now, ionization potential. Ionization potential is given as 13.6 volt. Ionization potential is same as the ionization energy, that is 13.6, but instead of writing volt, you have to write it as electron volt. Electron volt. So this is nothing but the ground state energy, that is energy in the first orbit. But what they are expecting then? They are expecting to find the energy required to remove an electron in the n equals to the second state. So in the energy level diagram, students, you have written the energy of the first orbit in the hydrogen atom as minus 13.6 electron volt. What is the meaning of this energy? What is the meaning of this energy? Electron, whatever is there in the first orbit, that electron can be removed. The electron can be removed from that orbit by supplying a energy of minus 13.6 electron volt. So that is the meaning of this. This energy is called as ionization energy. So ionization energy means the energy required to remove the electron from the orbit. What is the ionization energy in the first orbit? Ionization energy in the first orbit is minus 13.6 electron volt. Now, can you go with the second state? Yes. N is equal to 2. Second state. How to find the energy in the second state? You know that it is nothing but E1 divided by N squared. Here E1 is 13.6 divided by N squared is 4. So 13.6 divided by 4 will be 3.4 electron volt. So what is the energy in the second orbit? 3.4 electron volt. What is the meaning of this, students? If the electron is there in the second orbit, whatever the electrons are there in the second state of the hydrogen atom, to remove this electron, how much of energy we require? To remove this electron, 3.4 electron volt energy is required. 3.4 electron volt energy is required. That is option D. So what is the energy required to remove the electron in the second orbit? To remove the electron in the second state of the hydrogen atom is 3.4 electron volt. They're asking you to find that itself in the second state. I hope you got the difference between this ionization potential and ionization energy. So only the thing, if you express the potential in terms of volt, the energy must be substituted in electron volt. The energy must be substituted in electron volt. Yeah. come to this. Ionization energy of 10 times ionized sodium atom. You know that sodium is represented with 11. What is the atomic number of sodium? Atomic number is Z, that is 11. What is the meaning of 10 times ionized? What is the meaning of ionized? Ionized means the removal of an electron. Removal of an electron is called ionization. Removal of an electron is called as ionization. If you say 10 times ionized means what? 10 times ionized means in the sodium atom, there are 11 electrons. If this is 10 times ionized means, 10 times ionized means we have removed 10 electrons. We have removed 10 electrons. If you remove 10 electrons, what will be the left out electron? Left out electron will be 1. So you can consider 10 times ionized sodium as a hydrogen-like atom. You can consider this as hydrogen-like atom. Hydrogen-like atom. So if it is an hydrogen-like atom, you can apply the Bose postulate to that. According to the Bose postulates, energy is given by the formula minus mz square e power 4 divided by 8 epsilon naught square n square h square. This is the energy in the nth orbit of general atom. For hydrogen atom, energy in the first orbit is called minus 13.6 electron volt. But they are not expecting for the hydrogen atom. They are expecting for the sodium. So for sodium, energy is directly proportional to Z squared, isn't it? If you are coming from hydrogen to other than hydrogen atom, like hydrogen-like atoms, because pretty well you know that the Bose theory is applicable for both hydrogen as well as hydrogen-like atoms. So, for sodium, if you go with the 10 times ionized means, it is a hydrogen-like atom. If it is a hydrogen-like atom, energy is directly proportional to Z square. You can take Z squared times of the energy in the hydrogen atom. So what is the energy in the hydrogen atom? It is 13.6 electron volt. For that, it is multiplied with the Z squared. For hydrogen atom, Z value is 11. Therefore, option D is the correct answer. So for sodium, Z value is 11. Therefore, energy, ionization energy in the sodium atom is 13.6 into 11 square. So which is the right option? Option D is the right answer. Yeah, come to this. The following diagram indicates the energy level of the certain atom. When the system moves from 2e to e, a photon of wavelength lambda is emitted. So let me write. This is 2e. This is 4e by 3. That is the 4 by 3. 4 by 3 is 1.33, right? Then the another ground energy is E. So these are the three orbits they have given. One is 2e, another one is 4e by 3, the third one is E. 4e by 3 is 1.33. Now, what is the other data they have given? They're telling that when the energy comes from 2e to e, wavelength emitted is lambda. This is 2e, this is e. From 2e to e, the wavelength emitted is lambda. Now, what they are expecting? What they are expecting? What is the wavelength? When photon is coming from a transition, it is taking a transition from 4e by 3 to 3. What is this wavelength they are expecting? Let it be lambda dash. Yeah. Now, when when the photon takes a transition, from 2e to e, what is the energy emitted? Final energy minus initial energy, which is nothing but hc by lambda. What is 2e minus e? It is e. So e is equal to hc by lambda. This is for the first case. Coming to the second case. When electron takes a transition from 4e by 3 to e, 4e by 3 minus e, 4e by 3 minus e, this transition 4e by 3 to e, this energy difference is hc by lambda dash. Correct, no? When the the photon takes a transition from 4e by 3 to e, the difference in the energy is 4e by 3 minus e, that is equal to hc by lambda dash. So what is 4e by 3 minus e? It is e by 3 if you take out the LCM. E by 3 is equal to hc by lambda dash. Can you substitute this value of E here? That is hc by lambda. This 3 as it is, which is equal to hc by lambda dash. So you can cancel out this hc and hc. Do the cross multiplication. Lambda dash is equal to 3 lambda. Lambda dash is equal to 3 times of lambda. So whenever the energy is coming, whenever the photon is coming from 2e to e, if lambda is the wavelength emitted, then electron takes a transition from 4e by 3 to e, then the wavelength emitted is lambda dash, that is equal to 3 lambda. So option D is the right answer. Yeah. Yes, students. This is a very important problem. This is quite important problem. The radius of electron in the second stationary orbit. They have not given the first orbit. Be careful. They have given the radius of electron in the second stationary orbit is r. So let me write the diagram for you. Let this is the first orbit, n is equal to 1. The radius of the electron in this orbit is r. No, sorry, not r. Because they're telling for the second orbit, the radius is r. They have given the radius for the second orbit, that is r. Radius of the second orbit is given r. Now what they're expecting? They're expecting the radius of the third orbit. Radius in the third orbit, n equals to 3. R3 they are expecting. Yeah. What is R2? What is the radius in the second orbit is given? R. Now, you don't know what is the radius in the first orbit, students. Assume radius in the first orbit is x. This is we are assuming. Because I don't have any formula to write the radius of the third orbit in terms of R2. No, I don't know. I don't have any formulas. But if you know the radius of the first orbit, you can find the radius of the second orbit. You can find the radius of the third orbit in terms of R1. But we can't write directly the radius of the third orbit in terms of R2 directly. Therefore, I am assuming the radius in the first orbit of the hydrogen atom is x. Yeah. From Bohr's radius, you know that from the Bohr's concept, you know that radius of the nth orbit is always equal to the radius in the first orbit into n squared. So radius is directly proportional to n squared times of the radius of the first orbit. Now, can you write the formula for the radius of the second orbit? What is the radius of the second orbit? It is n squared. So 2 squared. 4 times of R1. What is R1 we have assumed? X. What is the radius in the second orbit? 4 times of x. Then, can you tell me the radius of the third orbit? Radius in the third orbit. Radius in the third orbit is n equals to 3. So it will be 3 squared times of R1. So it is 9x. R3 is equal to 9x. Now, if I divide R3 by R2, what I'm going to get? If I take R3 by R2, R3 by R2 is 9x by 4x, which is equal to 9 by 4. So what is R3 from this? R3 is 9 by 4 times of R2. What is R2 is given? R. What is 9 by 4? 2.25. So what is the radius of the third orbit in terms of second orbit radius? Because second orbit radius is given R. What is the radius of the third orbit? Radius of the third orbit is given by 2.25 times of R. So which is the right option? Option B is the right answer. 2.25 R. Got it? Yeah. This is quite important, students. Similarly, they can ask any orbit. Not only the third orbit by giving the second orbit radius. Yeah. Come to the next problem. Which atom they are talking? Yes, they are talking about the hydrogen atom. What is ionization potential? It is 13.6 volt actually. Ionization potential is 13.6 volt. Ionization potential is 13.6 volt means what is the ionization energy? It is minus 13.6 electron volt. What is the ionization energy? Minus 13.6 electron volt. Now, from where to where the electron is going to take a transition? Third excited state. You know that this is the first orbit. This is the second orbit. This is the third orbit. This is the fourth orbit. If the electron takes a transition from 2 to 1, this is called the first excited state. First excited state. This is called the second excited state. Then this is called the third excited state. So clearly, can you tell? Third excited state means what is the orbit number? 4. First excited state means n equals to 2. So now the electron is taking a transition from 4 to 2. Electron is taking a transition from 4 to 2. Now they are expecting you to find the energy of the photon. You know that the energy of the photon when it comes from 4th orbit to 2nd orbit is E4 minus E2. What is the energy in the emitted in the system in the hydrogen atom when it comes from 4th orbit to 2nd orbit? That is E4 minus E2. What is E4 minus E2? Now, you know that energy in the first orbit is minus 13.6 electron volt, and you can find the energy in the nth orbit by using this above, that is E1 divided by n square. So energy in the nth orbit is given by energy in the first orbit divided by n square. So this clearly tells what is the energy in the second orbit. It is minus 13.6 divided by 4, minus 3.4 electron volt. What is the energy in the 4th orbit? Minus 13.6 divided by 16, right? That is minus 0.84 electron volt. Clear? After knowing the energy in the second orbit and the 4th orbit, can't you calculate what is the energy emitted? Energy emitted is E is equal to E4 minus E2. Therefore, E is equal to, what is E4? Minus 0.84 minus E2 value is minus of minus plus 3.4. What is 3.4 minus 0.84? Approximately it is 2.5 something, or you can go with the 2.55 electron volt. Option B is the right answer. Option B is the right answer. Got it? Any doubt? Yeah. Let us take up the next problem, students. The figure indicates the energy level diagram of an atom, and there is an origin of 6 spectral lines. They are named as 1, 2, 3, 4, 5, 6. The line number 5 arises from the transition from B to A. Line number 5, this. Line number 5 is the transition from B to A. So similarly, they have given one example. Similarly, what you can tell, the first line, the line number 1, is taking a transition from C to X. Second line is taking a transition from B to X. Third line is taking a transition from A to X. Like that, and so on. For this absorption spectrum, you have to choose the following spectral lines which also occur in the absorption spectrum. Which can also occur in the absorption spectrum. In terms of line number they are talking. Definitely you can't take 1, 2, 3, 4, 5, 6. All the lines can't be in absorption spectrum. 4, 5, 6 is one set. 1, 2, 3 is one set. 1, 4, 6 is not possible because this is not in the symmetry. So you have to tell the following spectral lines which also occur in the absorption spectrum. Now, this state 1, 2, 3, they have reached the ground state. They have reached the ground state. Now, but still the 4, 5, 6, still it is in the higher excited state where it can absorb the energy or it can emit the energy. It can go with higher orbit or it can come to the lower orbit. So which are the lines occurs in the absorption spectrum? 4, 5, 6. Because all these three lines has reached the ground state. It is in the ground level. So we can give the energy easily for the higher orbits. So which are the lines which will be in the absorption spectrum? 4, 5, and the 6. So you can go with the option B. Yes. Come to this next problem, students. Here you have to be a very, very, very careful, students. When a hydrogen atom is raised from the ground state to the excited state, observe here, first orbit, second orbit, this is the infinity. What is the energy in the infinity? Energy in the infinity orbit is 0. What is the energy in the first orbit? Minus 13 point something electron volt. Energy in the second orbit is minus 3 point something electron volt. So as orbit number increases, if you go from ground state to the higher state, actually the total energy has increased. Total energy has increased. Sir, look at the number. Here it is 13, here it is 3. How can you tell it is increased, sir? No, negative sign is there. So if you look the higher orbit, what is the energy in the infinite orbit? 0. 0 is more than the negative value, isn't it? Energy in the first orbit is negative. So energy in the infinity orbit is 0. So energy in the higher orbit is more compared to the ground state energy. So total energy is going to be increasing. You know that the total energy and kinetic energy are same. This total energy will be negative. Total energy and kinetic energy are same, but kinetic energy will be a positive value. So what is the kinetic energy in the first orbit? It is plus 13.6 electron volt. If you write with a positive sign, kinetic energy in the first orbit will be more. Kinetic energy in the lower orbit will be less. So if you raise the atom from ground state to the higher state, kinetic energy has to decrease. Because kinetic energy is positive. As orbit number increases, its velocity will decrease. Therefore, its kinetic energy has to decrease. But the total energy is not like that. Since the total energy goes with a negative value, total energy has to increase as the orbit number increases. And also, potential energy also increases because potential energy is also negative. Potential energy of the hydrogen atom is negative. Since the potential energy of the hydrogen atom is negative, as the orbit number n increases, the potential energy has to increase. So what is the final conclusion, students? Whenever this hydrogen atom is raised from the ground state to the excited state, total energy has to increase. But in the options, they are not talking about total energy. They are talking about the kinetic energy and potential energy. Now the kinetic energy has to decrease. Potential energy has to increase. Look at the first option, students. Potential energy increases, kinetic energy decreases. Potential energy increases, kinetic energy decreases. So option A is the right answer. Any doubt related to this? Okay. Yes. Come to this problem, students. Now, electron makes a transition from fourth orbit to the second orbit. What is the wave number they are expecting? You know that the meaning of the wave number is nu bar. That is the reciprocal of what? The wavelength. You know the formula for 1 by lambda has what? R into 1 by n1 square minus 1 by n2 square. So nu bar is equal to R. I will keep as it is. Now the electron is taking a transition from 4 to 2. It is taking a transition from 4 to 2. This tells the lower orbit is 2, higher orbit is 4. So what is 1 by n1 squared? 1 by 4. n2 squared is 1 by 16. So what is the LCM? 16 is the LCM. It becomes 16 minus 4, that is 12. So 12 by 16 means 3 by 4, right? 4 3s are 4 4s are. So 3 by 4 are. 3 by 4 are. So you do one thing. You can go with the option B. It is not 2 by R. It is 12 by 12 R by 16. It is 12 R by 16. So 12 R by 16. So option B is the right answer. 12 R by 16. That can also be taken as 3 by 4 R. But 3 by 4 R is not there. I think option B is it is not 2 R by 16, because instead of giving 2 by 16, they can go with 1 by 8 also. But maybe a printing error. So it is 12 R by 16. So option B is the right answer, students. Yeah. In Bohr's model of the hydrogen atom, lowest orbit corresponds to what? Lowest orbit means what? This is the first orbit, n equals to 1. This is the second orbit, n equals to 2. Like that, this is the infinite orbit. Now they are asking you to find the lowest orbit. So which is the lowest orbit? The first orbit is the lowest orbit. Lowest orbit is the first orbit. You know that what is the energy in the first orbit? It is minus 13.6 electron volt. What is the energy in the inner orbit? Minus 13.6 electron volt. So it is not zero energy. It is not an infinite energy. Then what? Then what? It is a maximum energy or a minimum energy then? You know that as this orbit number increases like 2, 3, 4, 5 and so on, its energy value goes on increasing. So if the orbit number increases, the energy value increases. Then in which orbit the energy will be minimum then? This itself is the minimum energy, right? So the lowest orbit corresponds to the minimum energy actually. This is ruled out. It is not the maximum energy. Actually, to remove the electron from the first orbit, you have to supply a maximum energy. The supplied energy is maximum, but the orbit corresponds to the lower orbit is having minimum energy. Don't get confused, students. Minimum energy is in the first orbit, but to remove the electron from the first orbit, you require a maximum energy. To remove the electron, you require maximum energy to remove the electron from the first orbit. But first orbit corresponds to a minimum energy. Therefore, option C will be the right answer. Got it? Okay. I will stop at this stage, students. Let me continue in the next session. I hope in the next session I can complete this chapter. Then we can go ahead with the next coming chapter, that is nuclei. Fine, students. Thank you.